So number 1, at a school festival, a colored chip is randomly drawn out of a bag. The table below shows the percentage of randomly drawing of a specifically colored chips from the bag. If the bag contains a total of 50 colored chips, how many green chips are in the bag? Well, these all have to add up to 100%. Please write down everything I ask you to. These have to add up to 100%. So if you take your calculator, again, I've asked you to have a calculator, so if you don't, run and get one. And if we add these up, I have 14 plus 22 plus 10 plus 38. So add up all 4 percentages given, and I come up with 84%. So what is the missing percentage? Well, if they have to add up to 100, the missing percentage is 16%. So let's write 16% in this area. And then I'm literally going to highlight what the question is. Because much of the probability questions or problems, the confusion is what are they asking us? So they're saying if there's 50 colored chips, how many of them how many contained in the bag are green? So we take the percentage of green, and I have to write it as a decimal, and I take it times the number of chips in the bag, which is 50. This is going to be your estimated amount of green chips in the bag. So please take 50 times 0.16 at this time. And I have an answer of 8 green chips. Can you do me a favor right now? Okay, I want you to be totally honest and don't be embarrassed if your thumb is going down. Thumbs up to the side or down based on your understanding of that problem. Okay, we have enough of them here that I don't feel like I need to do another one like this tomorrow. Go on to number 2. Every year, approximately 1 million high school graduates begin their undergraduate careers at a 4-year college or university in anticipation of earning a bachelor's degree. According to the Education Trust, a nonprofit organization based in Washington, D.C., the probability that a student will earn a bachelor's degree in 4 years is 38%. I created this question for the review last year. So that means out of everybody that starts in a university, that's not Trevor Brown kids, that's everybody that starts in a university, only 38% will actually earn a degree after 4 years. What is the probability that a college student will take more than 4 years to earn a degree? Well, let me first say that this is assuming that everybody in this pool of the percentage is going to earn a degree at some point. Either you earn in 4 years or it takes you more than 4 years. Note that the percentages have to add up to 100%. So 100% minus 38% is, grab a calculator, %. At this time, we are going to skip number 3. I think I can get through more problems that will potentially be on the test. And if we have time, we will come back to number 3 and 4. Please go to number 5. Now for number 5, it's kind of like this problem. How many of you have ever seen a problem like this? Literally, I'm going to ask you to raise your hands if you have. Let's say we have a tire and something like this. And you're asked a question about if you're told this distance and you're told this distance, can you come up with the area of the outside tire? Has anybody ever done those before in geometry? You have. Okay, that's going to help me right now. Okay, so here we go. Please read number 5 to yourself. So I'm going to underline or highlight, depending on what you have. What is the probability that a point chosen at random is in the shaded region? So here's how you end up with this. Please write this down with me. We're going to take to get the percentage of a point randomly chosen and landing in the shaded region, we're going to take the area of the large region, and we're going to subtract the area of unshaded region. And then we're going to divide it all by area of large shaded region. so we have a square. We have a square here. So to find the area of the large shaded region, or the large region it should be, the area of the large region, it's going to be pretty easy. Okay, this is 1, I can see. This is 2, and this is 1, which is equal to 4. So this is 4 by 4, because it is a square. 4 times 4 is 16. So I know this portion is 16, and this portion is 16. It should just be the large region. Now I need to subtract from that area of 16 square units, I need to subtract any of the areas that are in white, the unshaded region. So if you took these 4 pieces and you put them together, do you see how you'd come up with a circle? What would be the radius of the circle that's formed? Tell your partner, not me. What would be the radius? The radius, not the diameter. What would be the radius of the circle that's formed by these 4 pieces? Radius is, anybody want to share with me? Radius is 1. Make sure your partner understands 1. Here's where it comes from. It's half the length of the circle. If we cut these all out, we could put them together and we'd get a circle that looks just like this. So if I put together these 4 portions, called sectors, and I look at this one, I can see that I have 2 circles exactly the size. Do you guys see that? I have 2 circles. So in this portion, what is the area of the unshaded? Well, I have 2 circles that are this size and I want to go with the area. So I have 2 circles, so I'm going to put a 2 down. And then I will need to go, okay, how do you figure out the area of a circle? It is pi r squared. Well, r is 1. 1 squared is 1. Okay, we did everything that's hard. Now the rest is going to be on the calculator, so it's not stressful. Please grab your calculator. We have 16, 16, subtract, I know 2 times 1 is just 2, so this is 2 pi. We are not using 3.14, we're going to actually use the pi symbol. So you hit the blue button, go straight, I got to find it here. Go to the caret key, which is above the division sign. Once you have this, let's press enter for the numerator, and then let's divide it by 16. Okay, so we are going to get an answer, and we need to round it to the nearest 1/10 of a percent. So this is 60 point, do I keep it at a 7 or do I bump it up? Keep it. So 60.7%. So let's say you're not very good at throwing, like Felix, okay? Not very good at throwing. And we give him a dart, and we say, Felix, can you guarantee me if you throw at this board, you're going to hit the board? And Felix says yes, okay? And so we figure out what's the percentage of him throwing at the board, guaranteeing he's going to hit this board, and it's going to land at the shaded region. The answer is 60.7%. Okay, that's a much tougher problem, one of the tougher ones you'll do today. So be honest with me, thumbs up, to the side, or down. Okay, we will definitely do another problem like that tomorrow, okay? Thank you for your feedback. Go on to number 6. Please make sure you have out that paper from yesterday which contains the formulas like you see on the whiteboard in front of you. Yesterday we learned about finding the probability of x and y. So we learned about when you're given, find the probability of x or y, and then when you're finding the probability of x and y. So everybody find that in your notes because you have to have that. Sebastian, could you do me a favor and jump up and look on the board? And can you please point to the very last formula for me so everybody can see it? There's only one and statement. Does everybody see that? Okay, this is if they are independent events. So I'm going to write that down here. We're told they're independent, so we're going to use this formula. P of, and instead of using x and y, I'm going to write a and b. P of a and b equals P of a times P of b. This is when they're independent, and we're told they're independent in this problem. Okay, so I know P of a is 0.24. I don't know P of b, so I'm just going to write x. So I have, here's P of a times P of b. I don't know that, so I'm going to put an x. And I know that P of a and b is 0.048. So if we need to solve for x, I can see that this quantity times x is being multiplied. Opposite of multiplying is dividing. And now I've solved for x, which is really P of B. So can you please divide these on a calculator? I have an answer of 0.2. What is 0.2? It's your missing value here. So P of B, the probability of B, is 0.2. This is a formula you have to have memorized. Really, there's only 3 formulas from this section that you have to have, 3 or 4 memorized formulas. This is one. So when you're given the AND statement and they're independent events, you are multiplying the probabilities. Please help me out with this. Thumbs up to the side or down so I know for tomorrow. Okay, here we go. Next page. Have one person read number 7 for me, please. Okay, so here we go. We have 2 different containers. I am not an artist, but you're going to do this with me. Okay, there's one container. Please do that for me. Here's the second container. In the first container, we have 6 peppermint. So I'm going to make those red. We have 6 peppermint, and we have 4 butterscotch, which is going to be blue for me. And we have 4 butterscotch. In the next container, container number 2, we have 5 butterscotch. And we have 3 peppermint. The question is, if a candy is randomly drawn from each container, so 1 candy from each container, and we're going to underline the question, what is the probability that the candies are drawn in both containers are peppermint? Okay, so what we're looking for is this. We're looking for, please write this down. We're looking for what is the chance of having the probabilities of being peppermint and choosing peppermint again. So first you have to know, are these independent or dependent? If something is independent, the second event you do has no effect on what happened the first time. So answer this question with your partner when I'm done with it. If I go to this candy jar and I pick out 1 piece of candy, my hope is getting a peppermint. Does that have any effect on me going to the second jar and hoping to get peppermint again? Tell your partner yes or no. If it has no effect, please write dependent in this box. We'll explain why in a second. If it has no effect, so we consider these independent events, then we're going to go, what is the chance of getting a peppermint? 6 out of 10 times, what's the chance of getting peppermint again? 3 out of 8. Grab your calculator, please. 6 divided by 10 times 3 divided by 8. Whoop. Okay, let's turn it back into a fraction. And these would be your acceptable answers. I would totally accept 9 out of 40, or I would accept 0.225. What is not acceptable is 22.5%. Circle the word probability. When they ask for probability, they're asking for a fraction or a decimal answer. Do not turn it into a percentage unless it says what is the percentage. Now, explain why these events are independent. Sorry, they're independent. And here's my answer. You can write down your own answer. The probability of randomly selecting a peppermint candy from container 1 does not affect the probability of randomly selecting a peppermint from container 2. Thus, the 2 events are independent. I'll say it again. Is there a chance you'd have to answer a question on the AZM and explain why it's independent or dependent? Absolutely. So here we go. The probability of randomly selecting a peppermint candy from container 1 does not affect does not affect the probability of randomly selecting a peppermint candy from container 2. Thus, the events are independent. Your feedback tells me what I need to go over tomorrow to make sure you're as prepared as I can prepare you. Thumbs up, to the side, or down on these two portions. Okay? Does everyone like it? Here we go. Please look at number 8. Number 8 is very much like number 7 with a little bit of a twist. Have one person read it out loud, please. Felix, paying attention, kiddo? Thank you. Okay, you ready? So, again, I'm a visual person. It is difficult for me, and everybody has a different learning style. It's difficult for me to learn without being able to see something. So let's go over here, find a space, and I'm going to draw a bag here. You're like, really, miss? Is that your bag? That's my bag. So there's the ties. There's the bag. Okay, so MISSISSIPPI. So how is this one different? Please box in or use your highlighter to highlight where it says, okay, so we have them randomly drawn without replacement. So this time, we have what appears to be two events happening. We're going to first come down and talk about this problem, and we'll come back and do A afterwards. What is the probability? I'm going to circle it and write decimal or fraction. They are not asking you to turn it into a percentage. It would say percentage if they wanted you to rewrite it as a percentage. What is the probability of selecting an S? So you randomly choose one, and you get an S. So let's write probability of S, and we're going to follow that up with the probability of a vowel. Now here's the kicker. You have this bag. You go in, and you choose an S, okay? You just happen to get lucky. You get an S. Can somebody tell me how many S's we have out of how many total?
4.
Okay, I see it. Oh, are there 4? There are 4. How many total? I have 11. Yes? Now here's the kicker here. You take that S, and it says you don't replace it. You put it into your pocket. And then you're going to do the second event. So, much like the and up above, we put a multiplying here. But now you're going to go back for the second event, and you're looking for a vowel. So how many vowels do you have? I'm going to cross out one of the S's. We got lucky, and when I dove in for the S without looking, I randomly chose a tile, and it was an S. So how many vowels do we have? 1, 2, 3, 4. 4. But here's the deal. You can't write 4 out of 11 for the next fraction because 1 tile's in your pockets. How many do you have? 10. We call this dependent. And if somebody said, why is this dependent? This is what you could say. The probability of randomly selecting a tile, such as S, and not replacing it, I would write this down even though the question doesn't ask you to write it down. I think it's good practice, so I'll start again. The probability of randomly selecting a tile, such as S, and not replacing it does affect the probability of randomly selecting a second tile, such as a vowel. Thus, the two events are dependent. The probability of randomly selecting a tile, such as S, and not replacing it does affect the probability of randomly selecting a second tile, such as a vowel. Thus, the two events are dependent. So, how do we get an answer here? We're just going to take the 2. 4 divided by 11 times 4 divided by 10. And there's 2 ways to accept this answer. One is as a fraction. Remember, we never want to round unless it asks us to. So there's one answer that's totally acceptable. And we can see here that I don't want to write down the decimal because the decimal does not terminate, it doesn't stop. So if I wrote down 0.145, if I wrote that down, I would be rounding, okay? So let's write it as a fraction. What would be correct? Let's see if there's a pattern. 45, 45, 45. So 0.145 repeating like this would also be acceptable. I would accept those on a test in my class, but let's be safe. On AZ Merit, let's just write it as a fraction. You may be thinking then, Miss, so I know that when we have and statements, I'm going to multiply. But how do I know when they're dependent or independent? When you don't replace something, they have no effect on each other. Sorry, take this back. When you don't replace, so the second event is affected by the first, it's dependent. Okay? When we have 2 things that do not affect one another, it's independent. Or if you replaced a tile, it'd be independent. Let's go on to number 9. Before I do that, I need to know if I need to practice another one like number 8. So thumbs up to the side or down so I can see. Thank you for your honesty. Okay? Number 9. 3 chips are drawn without replacement. Okay, that's huge. Without replacement. What does that mean if we're not replacing something? Dependent. Dependent, okay? 3 chips are drawn without replacement. And find the probability, circle that. That means we're going to do a decimal or a fraction, no percentage, of choosing a blue chip, followed by a red chip, followed by a green. So this is what we're looking for. We're looking for blue and red and green. So probability of blue times, I'm so sorry here, that was messy. Probability of blue times the probability of red times the probability of green. But the key is we are not replacing. So first of all, does it ever tell us in this problem how many chips we have total? Or how many jaws? So please do me a favor and add these up in a calculator and let's compare answers to make sure we have the same. I'm going to call on somebody randomly in just a second. Please add these up. Make sure you each have your own calculator. Go grab one if you don't. How many do you have when you add them up? 60. Okay, so what is the chance of us drawing a blue chip? This portion would be 8 out of 60. But the key is, I randomly choose a chip from a bag, in this case. I choose it, hey, I get lucky, it's blue, just what I wanted. And I take the blue chip and I put it in my pocket. So instead of there now being 60 chips, when you go back to this container, how many are there? 59. It's always going to be that way when things are dependent. You're always losing one each time. Okay, so now we look and we go, red. How many reds do we have? 12. But we no longer have 60 again because one of the blues is in your pocket, so we now have 59. Your last event is green. There are 16 greens in this container, but there are no longer 59. There are 58. Please use parentheses multiplying these 3 quantities. That is not a terminating decimal. Okay, so you'd have to round if you're going to write that down. Can we turn it back into a fraction? Okay, that's going to be our answer. 64 over 855. If you think did I make a mistake? Oh, thank you. This one says decimal. Thank you for helping me out. Can I help you with something really quick? Unless it says round to a decimal, then in this case you should leave it as a fraction, okay? Jesus pointed out that I did not continue to read this. It says express your answer as a decimal and round to the nearest thousandths. So, okay, we have tenths, hundredths, thousandths. So it's 0.007, I look behind the 7, it says don't round up. So 0.007 would be your answer. This is the exact answer, but this is rounded, and it does ask us to round. Thank you, Jesus. Thumbs up to the side or down. Please be honest with me. It helps me prepare you for tomorrow. Okay? All right, I'm going to see if I have a dice really quick. I'd like somebody to look at number 10. One person to read number 10. Go ahead. So I'm going to do one problem with you like this, and then I'm going to challenge you to do another one similar that I'm going to make up. Okay, I'd like you to highlight or underline the given information. So given that it's a multiple of 3, and we're only looking at numbers 1 through 50. So we've just taken, instead of focusing on 1 through 50, we're only going to focus on the numbers 1 through 50 that are multiples of 3. When I say go, you're going to have 30 seconds as quick as you can to do what I'm doing. 3, 6, 9, and keep going until you get 250, but you're only going to do multiples of 3. Write them all down. Don't count them on your hands. Write them down. Go. So I've put down all the multiples of 3 between 1 and 50. Now the next thing is we need to count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Put 16 on the bottom. So I have 16 choices to choose from. The next part says, what is the probability? Again, this is a fraction or a decimal, not a percentage. What is the probability that of those given, which is a total of 16, that I have an even number? So if I randomly choose from these, what's the chance of me getting even? Let's circle all the evens. One, 2, 3, 4, 5, 6, 7, 8. So 8 over 16 is right, but what's a better way to express 8 over 16? 1/2, or you could write 0.5. First focus in on what is the given, because that's your new area you're going to be working with. And then of the given, please find the probability. Okay, you're going to try one in a second, but this time you're going to rate 1 through 5 how well you understood that problem. 1 through 5. Hands up high so I can see you right now. Okay, most of us are 3 or above, so I think you're capable of trying the next problem with your partner. Find a space maybe on, is there a back page here? Or maybe on the side where you can write this down. Okay, so I gave you just a normal die. Has 6 sides to it. Okay, all sides are the same, same shape. You have the numbers 1 through 6. Here's the question I need you to write down. Ready? Write this down verbatim, please. What is the probability that you roll an odd number? What is the probability that you roll an odd number given that you are guaranteed to roll a number greater than 3? What is the probability that you roll an odd number given that you're guaranteed to roll a number that is greater than 3? Okay, with your partner, you have 30 seconds. Go ahead. given that is greater than 3. Is that an answer for you? Okay, the given says greater than 3, so I know that this particular dice is 6-sided like I said, so here are my options. I'm going to focus on the given, greater than 3. So I only have 3 options. I put 3 in the bottom. Now we want to know what is the probability of receiving an odd number. How many odd numbers do I have? 1/3. How many are able to come up with 1/3? Okay, you're going to try another one just like it, this time without the help of your partner. Can everybody write down 1 through 6? We'll do an easy dice one again, 1 through 6. What is the probability that you roll an even number given that you roll a number greater than 1? What is the probability that you roll an even number given that you roll a number greater than 1? On your own, 30 seconds, go. Okay, greater than 1. This is the given information. And then I said even. So I'm only going to work with these 5. How many of them are even? 3 out of 5. So 3 out of 5 would be acceptable. 0.6, because it's a terminating decimal, would also be acceptable. Okay, for thumbs up for this type of problem, to the side or down. Very great job. Okay, let's move on. Finding number 11, please. You guys are doing very well. Have one person please read it.
After returning from summer break, Eric attempted to grade 4 students in his advisory class. None of them went on vacation with their families. Some worked, some did both actively, and others neither went on vacation nor worked. If you know that you know a student that answered and worked, what is the probability that all went on vacation expressed?
Okay, so here's a given, but they don't use the word given. Please circle this. You know the student worked, which means, hey, it's given that the student works. They just didn't use the word given. Hey, it's given that the student works. So just like where we circled the given numbers, we're going to circle the portion that says, yes, I worked. So find the work section. It's going to be on the side, and we're going to highlight or circle where it says, yes, I worked. Yes, I worked. That's the only region that you're going to work with. Now the next part says, what is the probability, decimal or fraction, that they went on vacation? So, went on vacation. Yes, I went on vacation. Out of how many total? 20. 13 out of 20. Please turn it into a decimal and see if it is a terminating decimal. Okay, so now we have these two answers, but then this is the probability. So 13 out of 20 or 0.65 would be totally acceptable. But then it says express your answer as a percentage. So your final answer would be written as 65%. So 65% of those who worked this summer also said they went on vacation. Would anybody like to try another one like that, because it is kind of confusing? Okay, thumbs up to the side or down then in your understanding. Okay. Flip to the next page, please. It's a little more work for 12. 12 is kind of like 4 and 5, where I think we can get through more problems and there'll be less confusion. So we this time are going to skip 12 and we're going to move on to 13. Have one person per group slowly read the problem, please. Okay, so So with your partner, you're going to take this information, you're going to see if you can fill these out. Okay, I'm going to give you 1.5 minutes, and I'm timing you right now. Begin. Start talking with your partner. Okay, so first one, what do you have, Jasmine, right here? Keep going down.
24,
And down again.
40,
Okay, next line.
20,
I agree.
6,
Yes.
26,
Okay, last one.
36,
Yes.
30, 66.
With your partner, you are going to refer back to that. And with your partner, I'm going to give you 3 minutes. Then I'm going to go around the classroom and get different ideas of answers. And we're going to compare them to find out which one we think is correct. You're going to do part B with your partner and part C. Please do me a favor. And can you leave your answer, regardless of what it says, can you leave your answer just as a fraction? You don't need to reduce it, okay? Until we actually decide what is the answer. Begin.
All of us purchase cars which is 66. What is the probability that a randomly chosen buyer is a male that purchases this car?
Sebastian, do you have an answer for part B? Okay, you're right. Can you give me just the fraction? Don't reduce anything.
20?
Only because I first want everybody to understand how are we getting these, and then we can reduce it afterwards and answer the question. Did anybody initially get, pay attention please, did anybody initially get 20 over 66 for the first one? About half of us. Do me a favor right now. Please circle for everyone who purchased cars. So how many people actually purchased cars? Okay, so we're choosing out of 66. And then out of the 66, we're going to focus on males who chose sports cars. Males who chose sports cars would be 20. Now let's go to the next part. Express your decimal to the nearest hundredth. So please take 20 divided by 66, and we're going to round it to the nearest hundredth, which would be 0.30. And the 3 doesn't bump it up, so 0.30. Remember, never round unless they ask you to. Next one is a given statement. So this goes back to what we just did in the previous problems. Given that you randomly, the randomly picked, not picker, the randomly picked buyer is a male. So come down to males and highlight males or men. So given that it is a male, the question for part C says, what is the probability he purchased a sports car? So 20 out of, in this section, 36. Hands up high if you happen to choose that. Impressed? Who would like to see one like 13 tomorrow just to practice again? Hands up high. Okay, thank you. Again, let's express this by rounding to the nearest hundredth. So 20 divided by 30, 6. Round to the nearest hundredth is 0.5. In this case, we have to round up 0.56. 14 is not easy, but in my opinion, it's a common sense problem. So choose one person to read it, and I want you to come up with a fraction. You don't need to write down your reasoning at this point. Begin. Only getting a 6 tells you go first. Sorry, only getting a 1 tells you go first. Only getting a 1 tells you go first. Okay, so I will be calling on a few people in this classroom. I start with 6 cards. We want to determine who's going to go first. So to go first, you end up drawing a number 1. So Clarelli goes first, okay? She chooses a card. Does she get to go first? No. Nope. Why not? Okay, so do I put this 2 back into the pile? No. Okay, so I'm not replacing it. When you don't replace things, by the way, what does that make it? Every write dependent down. All right, now it says we're guaranteed that the second person is going to somehow get number 1. Well, let's flip these over and see. So what is going to be our fraction that represents this probability? How many number 1s do we have? How many total cards do we have? Whoever's shorter between you and your partner, please make sure in the next 15 seconds to explain how is the answer 1/5. Go ahead. Here's how I would explain it. You don't have to write this down, but please listen. Here's how I would explain it, because it does ask you to explain your reasoning. I would say after the first person draws a card and it is not a 1, how many cards are remaining? 5. And of those cards, how many of them contain the number 1? 1/5. Flip to the next page. Whoever is taller between you and your partner, please read the top part of number 15. Okay, we're going to do part A together. Circle the word probability. Remember, that's going to be a decimal or a fraction. Okay, decimal or fraction, know that. Unless they ask for a specific way to write the answer, it's always going to be a decimal or a fraction. What is the probability of randomly chosen student will play a musical instrument, so M, and play a sport? Play a musical instrument and play a sport. How do we do and statements? Look at the board. What do we do with those? Multiply. We want P of M times P of S. These are independent. They do not, choosing one does not affect the other. So can somebody tell me what percentage goes with playing, what percentage goes with playing a musical instrument? Okay, so we'll write down 0.10. What percentage goes with playing a sport? So first you have to go here, and then underneath that column, look at your next 2 options. Which one is playing a sport? 38%, which is written as 0.38. Please multiply for me. Okay, now I think .038 is the answer. And yes, we could write that as a fraction, but let's go back and see how do they want us to write this. Express the probability as a percent rounded to the nearest tenth. So let's look at this. Percent would be 3.8%. Please only do option B. You have 30 seconds, go. By the way, this is an and statement. They're saying, plays a musical instrument and, what am I doing here? Does not, right? Play a sport. Go ahead. Oh, it's a neither, isn't it? Neither play. So no musical instrument is 90.90. And then from there, plays no sport is 7%, 0.07. Okay, we're going to round it again to the nearest tenth of a percent. 0.90 times 0.07. Rounded to the nearest tenth of a percent is 6.3%.